Let's go to right under back and backing weld detailing. Two other types of welds are the back and backing welds. While both are represented by the same weld symbol, they differ in that the back weld is deposited after one side has been welded and the backing weld is deposited after depositing the opposite side. All right, so that's something to remember there too. All right, a back weld, say we have a V-groove. We're going to take and weld that V-groove up. You know, we may try to put a stringer in there the best we can, or we may take two beveled plates and jam them together, run a pass and fill that joint all the way up, then come to the back side and carbon arc or grind that back side out down to clean metal. Then when we put that weld in, that's a back weld. All right. Now, if we take those two joints or those two beveled plates and we put them together, maybe leave a little gap there, and we go to the back side and put that pass in first, that's a backing weld. Then we come to the front and fill it up. All right? So you need to understand the difference between back weld and backing weld. That's something else get a little confusing. Into that paragraph. They can be differentiated by using a symbol with a note in the tail or by using multiple reference lines to show a sequence of operations. So this weld symbol for backing and back is the same thing. But in the tail, we can put a note there, right? Say backing weld or back weld or whatever you want to do. Just to clarify it a little bit more. Let's go to the right column, page 77, under stud weld detailing, second paragraph or second sentence. A dimension to the left of the stud weld symbol refers to its required size. The number of studs required can be indicated by a number enclosed in parentheses just below the stud weld symbol. To indicate the spacing of adjacent studs, a number can be placed to the right of the stud symbol. All right, so once again with these, we got parentheses telling us how many we have, and then we can put a number to the right that's basically talking about the pitch. All right, let's move on to page 82. The left column, supplementary symbols. It's going to be the second paragraph. First of these symbols is the weld all-around symbol. The symbol consisting of a circle around the junction of the arrow and reference line describes a weld that is to be continuous around the joint, despite abrupt changes in direction. So, we were going to weld this water bottle down here to this plate. We had an arrow pointing to this, a fillet weld. We may not know, do we weld just 1 inch weld here? Do we weld a 1 inch weld on both sides? What do we do with it? Well, if there's a circle right there in that junction between the arrow and reference line, that's telling us, hey, we need to weld all the way around that. So that's seal welding. So if you see that little circle around that junction, that's for a seal weld. That means that weld needs to be completely sealed off. You may have a T-plate, and it says weld all the way around. When they say that with a T-plate, you need to wrap your corners all the way around. Versus just putting a pass on one side, the pass on the other, you need to wrap them corners around. It says seal weld. A little further down, up the last sentence. The field weld flag is placed at a right angle to and on either side of the reference line at the junction with the arrow. All right, so that's pretty self-explanatory if you see a flag on there. If you're in a shop welding and you see a flag on there, chances are you're not making that weld. All right? They're either going to do that in assembly or they're going to do that out in the field and make that there. Right column up the top. The next commonly used supplementary symbol is the melt-through symbol, which can be used to describe weld penetration beyond the back surface of the joint. The melt-through symbol itself appears as a darkened-in backing weld symbol. The amount of melt-through can be detailed by including a dimension to the left of the symbol. So this symbol looks a lot like a backing and back weld symbol, except for it's filled in, right? And that's just talking about putting a stringer in it, right? Burning it in from that same side that you're working from. All right, let's go to page 87. We're going to be under finish symbols. The last group of supplementary symbols to be discussed describes the desired shape of the completed weld. Contour symbols for various configurations include flush, convex, and concave. The symbols for these contours correspond to the actual configurations desired. The letters outside the contour symbols represent method of mechanical finishing to produce the desired contour. The letter designations for the various methods are as follows. I'm not going to read through those. Pretty self-explanatory. Let's go to, actually on that for a minute. So let's say that we're making a weld on something. Maybe it's a groove weld, and we have a cap on there. But for whatever this is going on, we need it perfectly flat, so they're going to come back and they're going to machine that surface off. Right, so on the weld symbol, you might see an M for machining. Right, so they may designate a certain finish that they want on there, so they can, they can do flat, concave, convex, with grinding or machining or whatever they want done. I mean, typically in oil and gas with pipe and vessels, you're not going to see anything like that. I mean, we just kind of do what we do. But if you get into something else, you might see that happen. All right, the tail of the symbol. The final element of the welding symbol is referred to as the tail. While not considered to be an essential element of a welding symbol, the tail can be used effectively to convey other important information that cannot be conveniently communicated elsewhere on the welding symbol. When used, the tail is placed on the end of the reference line opposite the arrow. Typical information to include in the tail is procedure number, process type, specification number, filler metal type, need for back gouging, reference to other drawing details, need for NDE, etc. Right, so it's just, the tail is just going to be used for notes. All right, use of multiple reference lines, second paragraph. One way to describe this sequence of operations is to combine several individual reference lines on the same arrow, with each line containing information to be applied at a certain step in the welding operation. The convention is that the order of operations depends on the relative location of each reference line with respect to the arrow. That is, the first operation is described by the reference line closest to the arrow. Reference lines for subsequent operations will then appear in order, moving away from the arrow so that the last operation is described by the reference line furthest from the arrow. So that's a really long way of just saying the reference line closest to the arrow, if you have a bunch of them, that one close to the arrow is what you do first. All right, so you might see backing on there or melt through or whatever, and then they may show you V groove, and then maybe you got to do something else to it. So you're just going to work your way back from the arrow itself. All right, on page 89, they talk about NDE symbols. You guys may run into those one of these days. I have never seen an NDE symbol on anything ever. All right. We typically get our NDE instructions from customer specs or from code. So as an inspector, I already know what I need to do on every weld that's made. So I don't need a symbol on there telling me what to do. I've just never seen one. I'm not saying that you won't see one, but I've never seen one. All right.